Welcome to Dev Bootcamp Live, the podcast where we help you level up so you land your first engineering job and then you become the best software engineer on your team. This is Juan Lizarazo.
And this is Jared Potter.
And today, Jared, what are we going to talk about today?
Today, we're going to be talking about web security tips for the 2020 Frontend Software Engineer. So we're not going to get too deep into security here. We're going to keep it relatively high level on a handful of different topics that is focused towards you to help you as a front-end software engineer be able to implement basic security in your web apps so that you're, not running unsecure rather.
Okay,
so that's what we're going to be talking about today.
That sounds pretty good. But I want to change two things related to that. Let's say the 2021 security, right? Security for the 2021 software engineer. It's November. We have a month and a half left, right, in the year. So let's just talk about 2021. 2020 is over. And by the time you are listening out there to this, it's going to be 2021. Okay. So, security. I've been learning a lot about building high performance teams, right? That's what I've been doing for the last few years. And one of the important parts of that is that you have to have the built-in security, the security process built in your teams, so then you can have high-performance teams that can deliver software fast. And this just really means high level is that when you build something, you build a feature, you don't want to have somebody auditing 2 months later, or having an external auditing firm months later down the road when they find something, and then you have to go back, see the context, see the code, relearn it, right? That's not performance. So if you built in your development cycle, starting from product to the user stories, to the implementation, to delivery, and the team has ownership over that, you're going to minimize risk, and you're going to have a high-performing team that has built-in security and has a safer application that ultimately is going to protect your users. So really, Jared, that topic is really good. So let's start. What we're going to talk about first? What's the first item for this?
Yeah, so the first item is, honestly, it's just a basic. And, when it comes to security, you have to start from a foundational standpoint to build up. So this first tip is going to be more general to anybody, which is basically we're talking about passwords, password managers, and two-factor or multi-factor authentication. So, we've all heard things about passwords our whole lives and what you're supposed to do and all these different things. But as a software engineer, it's especially important to have a secure password. You might have eventually access to production environments, production databases. And if you're still using the same exact password that you've been using for the last 10 years, that's an issue. If your account ever got compromised or someone guessed your password based on another website being compromised, they could theoretically access your systems. And you definitely do not want that to happen and have it happen on your account.
And that's very important. We have seen in the last few years, big attacks to big companies. For example, a few months ago, we had the Twitter attack when a lot of accounts, high profile accounts, were compromised. And usually those attacks are done through social engineering, where people take over somebody's account, and that ends up being the lack of good, healthy security practices. So definitely have a password manager, auto-generated passwords. I personally don't know any of my passwords. I just know my master password, and that's it. I don't know any of my passwords. So anytime I need access, if I don't have my phone or my computer, I don't have access to what I need. So it protects myself but yeah, no, that's good. That's good.
Yeah, definitely. One method I would recommend for creating a master password is called the Diceware Method. So go online, Google it, go take a look. The short of it is that basically you take physical dice and you roll them, and based on the numbers that come up, they correspond to a word in the word list. And then you basically will get 5 or 6 words and kind of just tack them together. And it's been shown through research that the length of your password, and oftentimes security experts will encourage passphrases rather than passwords to encourage a longer password than a complex password. So that'd be one tip, to make sure that you're building a secure master password. And in addition to that, making sure that for whatever accounts support it, you're enabling two-factor or multi-factor authentication on your account. That's probably been the biggest bang for your buck in security in decades, is multi-factor authentication. So definitely get that turned on. But a quick point on password managers, Juan, which password manager do you use, or would you recommend?
I don't want to reveal it, so I'm going to keep myself safe. So no, I'm not gonna reveal it, but I know there's multiple out there. There's a lot of them. Like there's big high profile companies, there's free ones and there's paid ones. I do not use the browser built-in password manager. So the one from Chrome, I do not use that one because it can be insecure. If anybody gets access to your computer, they can just show all the passwords, list them, export them. So I don't use those really, but yeah. Which one do you use?
I use one that uses the key pass protocol, which a lot of pieces. I mean, basically, it's a protocol that a lot of software companies have built up a system on top of, so it's compatible with multiple systems. But there's other really popular ones out there. Like LastPass is honestly a decent option. It's a free option, free tier for a lot of people out there. If you don't have one, having one is better than not having one. So definitely recommend that.
Okay,
But again,
that's good.
I just wanted to lay that foundation to continue our conversation. That all this other stuff that we're talking about doesn't matter nearly perhaps as much if you don't have a solid security basics.
Yeah, always also password protect your computer. Always lock it when you are not around. Even if you're at work and you're with your best friends, lock the computer. When we were at work, Jared, we would just mess up with our team members that would leave their computers unlocked and type in their chats, type things that, hey, I'm buying coffee for everybody, but that's just to tell them like, hey, look, it's important that you lock because you cannot trust anyone when it comes to security.
Yeah.
Nothing is never secure enough. Okay, so what would be the next topic if we can start like diving in maybe into code practices or deployment practices? I mean, security is a big, like what are the most important things we should talk about today?
Definitely. So the kind of the next topic, more specifically, more closely related to code, would be understanding the difference between HTTP and HTTPS. Right. So we see these things in our browser at the top there, and like we're wondering like, what do they mean? Right. And we've always been told like, if there's not a little lock up there or it says HTTPS, never put in credit card information, never put in any sort of like sensitive personal information. Don't just, or passwords, don't put that type of stuff on that website. So Juan, could you give us a short bit about kind of what the difference is, and also what are perhaps easy methods or platforms that our web engineers can use to make sure their sites are using HTTPS?
Yeah, if you're building small applications or big applications, I mean, there's a lot of like I've been using lately Firebase, which it provides you add your domain, and it provides a free certificate, a free SSL certificate to protect your site with HTTPS. For example, if you use domains that are the .dev domains that you register through Google, you have to or through any register, but Google is the one that promoted that, you have to use HTTPS. You are forced to be using HTTPS. So HTTPS is just the use of a certificate, a SSL certificate, and that certificate is used for encrypting the content that goes from the browser to the server, right? Because when you visit a site, you're not just directly visiting that server. Your traffic is going through the network, is going through other servers, that intermediate servers, right, and providers connecting. That's how the world is connected. So you want to make sure that that content is automatically encrypted, and encrypted means that it cannot be like decodified. It's really difficult, right? It's really hard because these certificates have high encryption security. I think right now it's like 256 something. I mean, I'm not a security expert, but the certificate, what you do is that you install it on your server, and it's attached or is allowed for certain domains. Or if you have a wildcard certificate, it allows you to have any number of subdomains also. And there's also the assigned names. I don't remember the specific term, but you can have now certificates that work with other types of domains too. So they have to have those names also set, so it's fully secure. But the benefit of that is that if anybody's in the middle, like the man in the middle attacks, if anybody is listening to your traffic, somebody your Wi-Fi network's compromised and somebody is checking the traffic they will see when you visit a site that is under HTTPS is just going to be just weird text that they cannot understand. Even if you type your password, it's not going to be there. It's encrypted. So that's really just high level how it works. But for the web developer in 2021, really, like if you use things like Firebase or you deploy a static site, to GitHub and use that. They provide HTTPS for free, so you don't have to do a lot of setup with it, because setting up an HTTP certificate from scratch, it's and connecting it to your server is it's a complicated process. It's a lot of trial and error if you don't have experience with it. So you don't have to really spend a lot of time on that. Now in 2021, you have all these features that will do that with a click. Like in Firebase, it was like 2 clicks and it was done.
Yeah, no, I completely agree. Yeah, just another platform option out there that also provides HTTPS is Netlify. So when you deploy through them, they also have a certificate automatically pre-configured. So
yeah,
definitely use one of these platforms that just kind of has that all set up for you. Again, anyone who's ever had to set it up manually knows it's a big potential pain, and it's also very expensive. I mean, to buy your own certificate is, I think, a couple $100 these days.
But I was going to say that, like, now there's cheaper options. Like, there's no excuse to not have an SSL certificate. You can get a certificate as cheap as for $10 a year just for one domain. For example, I get mine through Namecheap. Namecheap has really good partnerships, and you can get a certificate for $10, $15, $20 a year. Or you want a wildcard certificate for multiple subdomains, it's like $40 a year. So really, there's no excuse to not have good security in your site. Also, the tendency with the web is that everything is moving towards HTTPS by default, because even if you don't have credit cards, but you're entering contact information, right? Or just login information, that has to be secured. You don't know who's watching what you're typing, your email, your personal information, maybe medical information. Like, you never know, right? So HTTPS should be the default, and that's where the web is moving forward. So now we have the HTTP that always redirects. Like, for example, if you use Brave, right, it's using HTTPS everywhere. It's always going to redirect to HTTPS when available. So it's really a very good practice, and you get a lot of security out of the box because all the traffic is going to be encrypted.
Yeah, that I completely agree. One small side bit I want to add is, I'm sure we all get advertisements from these consumer-based VPNs out there that talk about how if we don't use a VPN, then all of our traffic is basically unsecure, being sent in the clear. And that simply is not being true. It's just a marketing trick that's trying to get you to scare you to buy their product. If you're using HTTPS, then the connection between you and the server is secure. The only thing that is exposed is the domain name, which is like the address, right? Like if I send a package from my house to Juan's house, I have to write his address on the front of it. You can't hide that part, but everything on the inside is secure. So I know that's not specifically about web development, but it's, I think, an important thing that is out there, and I think we all see it and we get bombarded with it. But I think it's good to understand what it is or isn't doing, what a VPN is.
Yeah. Now that we're talking about entering information on a website and making sure that it's secure, I want to talk about from the web developer perspective, the software engineer perspective. One rule of thumb when you're building software, and this is for everybody building software and building forms or getting user input, like this is our commandment here, like you never trust user input. So when you're in the development side writing code and you capture code from inputs from the customer, let's say you are capturing usernames, password, different things, you never trust what they type. And that just really means you have to have some security practices in mind when you are dealing with user input. So let's talk about those, Jared. Like what are good security practices we have to keep in mind to comply with that commandment and never trust user input?
Yeah, so from perspective of being able to protect your database from the type of data it's being put in, or SQL injections or anything like that, we need to be able to look at the input that the user is sending, and we can't just trust it coming in. So generally this is coming from the perspective of the server, right? So when data is finally sent to the server to be processed, to be submitted, we want to basically go through two processes. One is validating the data, and one is sanitizing the data. So an example of validating data is, is the username, let's say we expect the username to be an email. Well, we want to make sure that, one, there's an actual value there, and two, it conforms to the format of an email. That would be an example of validating data. But let's say that, in addition to like the username and the password, or, whatever other contact information there might be, let's say they try to send a bunch of other fields along with it. Well, that's where sanitation comes in, where, we want to be able to, or you might hear it also called trimming the data. You only want to select the fields that you're expecting from the payload, because you can't control what a client sends to your server. At the server level, you have to kind of control that. So Juan, what are some basic ways in JavaScript perhaps that we control that or manage that?
And a good practice, like how you go is like, okay, you never trust user input. That means like when you capture the user data, a best practice is that you're going to save that data as is. And the reason is because if they go back to an edit mode, you want to show them like, hey, dude, look, this is what you enter, or sort of thing. But you're going to run some processes, which is the sanitization process. I mean, you cannot just like show it as is. I mean, you store it, right? But you are going to run this process when you store it. So two things you have to keep in mind. If you're building the API side of things or the database layer that persists the data, one recommendation is just always use a library or use a ORM or use a framework or use a driver, but not you don't write using low-level queries, because when you use low-level queries, you are at risk, for example, of SQL injection, right? And that's a very old school one, but that is still is a problem today. But if you use a good driver that uses a query builder, it's gonna clean that up, and SQL injection is not going to happen. So it provides, like, using these libraries are going to provide a lot of things out of the box. If you're using a framework, if you're using a library like Angular, or if you're using Vue, or even if you're using React, there's some security built in that protects you just doing it the Angular, the Vue, or the React way. Those things that if you comply with that and you don't hack around it, you're going to get a lot of security out of the box. So let's talk about the sanitization and the encoding process. So once you have the data stored, when you sanitize it, really, like if someone puts a script tag, for example, we don't want to just save that and then render it. Or if we save it, we just don't want to render it as is. We want to either sanitize it or encode it. So sanitization is removing these potential malicious attributes, right? Or pieces of the string like the script. Or if we want to show that data to the user, throw it back, we can encode it. So encode it, instead of removing it, we map it to the HTTP entity, HTML entity. So then when we render it in the browser, it can be rendered as the character. But if you look at the source, it's an actual HTML entity. So read about sanitization, encoding, HTML entity, so you learn the difference. And then don't mess up with the APIs and the things that the library you're using, because you don't hack them, because it's gonna protect you. And one of the important things of this, that why is so dangerous, is because it can open the door to cross-site scripting. So Jared, let's talk about cross-site scripting since we're on this topic.
Yeah, definitely. So kind of a quick bit into cross-site scripting is it's being able to, let's say, as a malicious person, I want to be able to convince someone else to run essentially some of my code on their website. And as soon as I essentially can run code on their website, I effectively have control over it, being able to potentially navigate on the site, or being able to potentially also scrape information, private information from the site.
Mm-hmm. Yeah, so cross-site scripting, just like you're running a script that does not belong to the site. And this, protecting from this, if you sanitize and encode, that's going to protect you from that, but it's not like bulletproof. You have to have good practices. Make sure you don't allow certain things. So for example, there's really like three types or three main categories for cross-site scripting. So let's talk about that. But first, I'm going to take a break, and I'm going to go ahead and share here the screen for a second, and let's talk about our Twitter accounts. So if you want to get in touch with us, or you have questions, just tweet at us, right? Maybe if you send private messages, we'll get around them, but sometimes there's a lot of spam and things. So for me, it takes a while. So you can follow me. You can follow me at twitter.com/Juan Lizarazo G, and that's spelled out JUANLIZARAZOG. And there's a follow button there. Follow us on Twitter. If you're not on Twitter, follow whatever platform you're listening or watching this on. We are in multiple platforms. And just tweet at us about like anything you need, and we'll be happy to help. Just get in touch with us.
Yeah, and everybody can find me at twitter.com/Jared Potter. That's JaredPotter. And yeah, please tweet at me, send me a private message. If you have any questions about security, feel free to send them on. It's a personal passion of
Yeah,
mine.
Jared is a big security um, fan. Like he really likes security and building the security process in the software development process. So that's really good. That's really good. So yeah, get in touch with Jared, asking questions about that. And we have the links to our Twitter accounts in the platform. So whatever you're listening this on or watching this on, just check the description. Our links are there, so you can easily follow us. You can just click on it and then just follow us. Get in touch. We like to hear from you.
Yeah, please do.
Okay, so the three categories, like it depends who you ask, but there's three main categories of cross-site scripting. So one is the basic one, which is the stored. And stored just means, let's say I have user input and I put some script tags there or an iframe or some HTML, and then the site I find that renders that as is. And now immediately I have access to render, let's say, an iframe that can render something from my site where I can capture your password, your bank account. I can run libraries to mine Bitcoin. I mean, I have seen that on the news lately too. Like there's like these different things. So that's the story. It's just storing the script, the code that can render that script. One that is very popular is the reflected one. And reflected is just when, for example, have you seen the query params? When you are using query params, you have to also make sure that you sanitize that input, because you never trust user input, no matter if it is your brother. You don't trust what they type. So what happens is, like the query params, right? You type, let's say you have a query and you type an email there or a name. If you type a script there, you can potentially execute it if it is just evaluated as is. So that's reflected because you can just put a, like, for example, I say, hey, Jared, look, this is the link. And I send Jared a long link. And now we're used to these super long links, right? And I can include there some JavaScript that is going to do something in his computer, right? Maybe do something that it shouldn't do. So that's a reflected cross-site scripting attack. And we have to protect from that by making sure you sanitize and you're aware of user input, and that is not limited to forms. That also limits to query strings, to URI params. So that in mind. And the last one is document object model attacks, which is just like a combination of the two, either stored or reflected. And instead of like executing JavaScript just to modify the JavaScript, it modifies the document. So for example, you can just do a query, get one element, and then insert an input that can capture a password or something, and then it's gonna post to a different site, right? So it's very important to have protection with that. And that's a cross-site scripting. I think we can maybe change topics unless you have anything else to add to it.
Yeah, no, I think it's just important to make sure that, yeah, that is implemented. Cross-site scripting protection takes place on both kind of the front end and on the back end, right? It's important to make sure that you have that covered in both places because
yeah, and as a
the
front-end
front end can be
engineer,
bypassed.
yeah, and as a software engineer, front engineer, you have the responsibility to take care of this. If you don't know about it, you're gonna introduce security vulnerabilities, and that's on you.
Thankfully, there's a lot of tools out there that you can leverage that will take care of a lot of this for you. It's just, researching them, being aware of them, and using them. So yeah, I think the next really important topic I wanted to touch on is this idea of authentication or user authentication. So there's a term out there that's called don't roll your own crypto. Have you ever heard of that term before, Juan?
I haven't, but I know where you're going with it. So tell us about it.
So what that kind of phrase means in general is that, crypto is short for cryptography. And all that we're kind of meaning by that is cryptography is a broad term to describe encryption. So when we, if we were to create our own user authentication system, we would have to take into consideration all these different security details to ensure that we are, handling passwords correctly, hashing them, making sure that we're using a salt with those, right? There's lots of different processes that have to be taken into consideration to have secure user authentication. So when they say don't roll your own crypto, all it's saying is don't build it yourself. Although, perhaps you could learn things, and I encourage people to maybe play around with crypto things to learn about them. But when it comes to actually implementing these things, I highly suggest do not doing it yourself. Don't create your user auth system. There are so many platforms out there that you could be using that provide state-of-the-art authentication with all the cryptography in mind and consideration there. So things like, Firebase authentication, Netlify has an auth provider, Auth0 is an auth provider. use one of these services when you're implementing user authentication on your site, because again, they've taken care of all of these details for us. And just to add one bit to that, and then I want to ask you, your experience with these things, Juan, is just a general point: don't ever store user passwords. There's no circumstance that you should ever have to store a user's password. Unless, there are very specific use cases like Plaid. Their platform is built on the idea of being able to store user passwords to your bank to be able to go and fetch that data periodically. But in general, don't ever store a user's password. And if you do, make sure that you know what you're doing.
What you mean is in plain text, right? Just as is, right?
Well, specifically as plain text, but in even a broader sense, I would discourage the idea, because I think that if you're, it opens up the possibility to possibly not be storing it. But yes, specifically plain text, don't be storing it as plain text,
Yeah.
So Juan, what's your take on this?
Yeah. There's two big things with that. Like when you implement authentication, you have to think about like user management, password resets, maybe two-factor authentication or multi-factor authentication. So the thing is like, and the signups and all these things, activations, emails, welcome email. So that by the time, like, let's say you implement all these things, by the time you implement all these things, you're 3 months into the project and you haven't written anything valuable to the product because you're reinventing the wheel. So the main reason to also do this is like, there's whole companies with whole security teams doing this for you. And on day one, you get all this out of the box, even for free. For example, Firebase, you get all of these things for free. So that's very important. And the other thing is that, okay, let's say you do it. Chances are like you're going to do it wrong, because remember, there's whole companies doing these with whole security teams and analysts and everything, right? And if you do it yourself, it's kind of like your chances are like it's going to work, yes, but you're going to do it wrong, that it's going to be insecure. You can maybe, okay, I'm going to use bcrypt. At least if you do it yourself, use an encrypting algorithm, not encoding, encrypting, so it cannot be decrypted, it because encoding is different. So keep that in mind. So then the password is never there, and then when you encrypt again, the password is never going to be the very same string. So then you use an encryption comparison to know if the password is the same, but you never know the password. So those are important things there. But yeah, never just integrate with a system, and then focus on the business, on the core business that you're trying to build, or the value you're trying to deliver.
Yeah, and you'd be surprised on how easy all of these platforms are to use. So I would encourage you, if you have never played around with one, and if you take away just even one thing away from this whole podcast, is go play around with one of these auth systems from Firebase, Auth0, or Netlify, and implement it into a site.
Yeah, and just like an added bonus, learn about the JWT or JAW tokens, whatever way you want to pronounce them, because they're widely used with those platforms. So that will give you a head start. Look, Google JWT tokens, learn everything you can about it. There's very good videos online on that, or maybe we'll do a podcast on that at some point. But yeah, so Jared, we're out of time for today, but security is such a broad topic that eventually we'll talk more about it. I think this is our second episode where we have touched security aspects, right? Because it's part of the life cycle. So let's do our recap, right? Let's talk about our recap. Let's recap our items. So just started talking with about a healthy password management policy, right? Using a password manager, right? So you have those secure practices. We talked about locking your computer and having your computer secure, right? Even don't trust your friends. Use HTTPS by default. It's really, in 2021, it's cheap and it's free to do it, and it's safer for your users. It protects you out of the box. Always use a library or framework. It has a lot of protections, and that includes the database layer also. We talked about cross-site scripting, right? We talked about the different types, so reflected, stored, DOM manipulation. We talked about SQL injection. We talk about authentication. Don't build your own authentication. What else did we talk about, Jared?
We also talked about just make sure, really solid security foundations, password managers, multi-factor authentication. Make sure you have that all turned on to your account. Use platforms that host HTTPS for you, so you don't have to do it. I think that's pretty much it. I think you covered it. But yeah, we'll definitely be talking more about security in future episodes. Still lots of things to consider and take away.
Awesome. So thank you for joining us today's episode of DevBootcamp Live, the podcast where we help you level up so you land your first engineering job, and then become the best software engineer on your team. This is Juan Lizarazo.
And this is Jared Potter.
And we'll see you next week.
Take care.